welcome to the first episode of Chemistry for Young Learners. This is Chem Explain. In this series of videos, we are trying to make some simple and basic concepts of chemistry really understandable for young learners. So let's waste no more time and start this. The first subject that we are going to talk about is the introduction to chemistry. Okay, what is chemistry exactly? We can say chemistry is the branch of science that studies matter, what it is and how it changes. But here we would have another question that says, what is matter exactly? To answer this, we can say anything that occupies space and has mass can be considered as matter, such as soda pop you drink, water, wood, metal, soap, and anything. The air that we breathe, all of them are examples of matter. Everything around us is matter. What other examples of matter can you tell? Try to write them in the comment section. Okay, let's have an example together so you can understand this part easily. We can say chemistry is like cooking. For example, when you're making a hamburger or doing any kind of cooking, you're mixing ingredients such as meat, you're mashing and grilling until you get a hamburger. Okay, the process that we talked about is exactly chemistry. But when we want to take it into science, we have some other words for them. For example, when we say matter in the process of cooking, we can say meat. Or the applying force which we have in chemistry in cooking is mashing. And the next step, we change the temperature when we are talking about the chemistry. But in cooking, we call this step grilling. And we do these process to get a new substance, which in this case, it would be the hamburger. Okay, so what other examples of chemistry can you tell us in real life? I mean, chemistry exists almost everywhere. So feel free to share your experience of chemistry in your real life experiences in the comment section. Fine. Now let's take a closer look at some possible answers or examples together. The first one's cooking, which we discussed earlier. It says the creation of food, how and why food rots. Or we can say cleaning, the creation and use of detergents, disinfectants, and soaps. On the other hand, we have medicine, the creation and use of drugs, vitamins, and supplements. And as the last and one of the most important examples, we have environment, which we can see chemistry widely. It says the creation and spreading of pollutants. Pollutant means a material, a substance that make the nature, the environment polluted, and the creation of materials to clean up and prevent pollution. Fine. There are possibly tons and millions of more answers for, let's say, uses of chemistry, but we are going to elaborate on them on the following videos and chapters as we go on. But if you want to mention some of them, we would be really happy to know your idea in the comment section. Let's head to the next part. Now we want to think and talk about the types of chemistry. As this major is really extensive and wide, it is divided into many different subjects. We want to learn that what is each subject and what does it study. Let's go. The first one is organic chemistry, which says the study of carbon containing compounds in both living and non-living things. When we say carbon containing compounds, we mean a chemical substance that has carbon atoms, such as the example we have here, methane gas. Or to understand it easier, we can have another example, which is ethanol. It is C2H5OH. It is the substance that we widely use in our hand sanitizers, and it is studied in organic chemistry. The next major would be inorganic chemistry, the study of everything except carbon-based compounds. For example, NO2 gas or SO3 gas, or any other substance that does not contain carbon or is not an organic compound. It is studied in inorganic chemistry. The next one is biochemistry, the study of the chemical processes that happen inside living things. When we say living things, it's not just human, but also any other living thing. Animals, let's say plants, and other things. The next major would be physical chemistry, the study of chemical systems as they apply to physics concepts. In this major, we mostly discuss on thermodynamics, kinetics, and some laws that apply for gases, and some more complicated concepts. The last one would be nuclear chemistry, which is the study of chemical changes in the nucleus or in the center of an atom. When we say the nucleus, we mean the smallest unit of matter, which is atom. Okay, that would be enough for now, but there are more majors of chemistry, such as analytical, such as polymer, such as medical, and we are going to talk about them as we go on, so do not rush into them. But if you're interested to know about any of these majors in details, let us know in the comment section. Fine, let's go to the next step. Scientists find evidence by conducting experiments and making observations. The process of using evidence from observation and experiments to create an explanation is called scientific inquiry. Scientists use a step-by-step method to answer questions. This is called the scientific method. It provides scientists with a systematic way to check their work and the work of others. Now, to get more familiar with this, let's check if there are any steps or any things about scientific inquiry. Scientific inquiry begins with a question or a problem. The scientist tries to collect all of the possible information that relates to the investigation of that question by doing background research, making observations, and conducting experiments. Background research involves reviewing the findings of past scientists to create a hypothesis, a possible explanation for an observation or problem. Scientists test their hypothesis by making observations and comparing them to their predictions. Guesses of what might happen based on previous observations. Observations can require using the senses, the way something looks, smells, feels, or sounds to describe an event. Observations can be quantitative, made in the form of measurements, and they can also be qualitative, describing color, shape, or some other physical characteristics. The findings of a scientific inquiry are called results. Now, if you think you're ready to answer some questions and you learned this part well, let's have a challenge. Can you tell the difference between scientific inquiry and scientific method? Feel free to type the answer in the comment section. You've got 15 seconds. Fine. Hope you're done, but if not, you can pause the video and continue typing. We would be really happy to read your answers. Fine. But let's see. Here we can say a scientific inquiry tries to answer multiple questions. It's not just one question. There are several questions or a group of questions which are related together, and we are trying to answer them. However, in a scientific method, we are trying to answer only one question. The second point says there is no fixed order of steps for scientific inquiry. The steps of scientific inquiry are completely based on what you're trying to find out and study, and they can be really different. But for a scientific method, a step-by-step process is done in the same order each time. Do not forget this, each time. And it's really important to remember that after a scientific method, results must be communicated. Fine. Now, let's have a short review and wrap this session up. Okay. Let's say you're a scientist and you want to do a scientific method. What things you should do and in what order should you do them? Okay, the first step is to ask a question or identify a problem. Next, you should conduct background research. After having background research, you have to create a hypothesis. Then, test the hypothesis with the experiments in the laboratory. Now, you should have make some observations and collect data. Analyze the results and draw conclusions. Now, in this step, two different things might happen. Maybe your results and your conclusions are the things that you already were searching for, and you got what you want. So here you're going to share your results. But sometimes if it's false, you should change variable and begin again from step 3. It means you should create another hypothesis for the second time and continue the steps another time. This might happen many times, and you need to repeat this process. Go back to the step 3 and try to make your hypothesis work with your data which are collected. Hope you like this video. If you're interested in more chemistry content, do not forget to subscribe our channel.